Hello, welcome to Mechanical Engineering Intellectuals. Today we are going to design a pneumatic circuit for speed control of double acting cylinder. In order to design a circuit, first we have to open the software, and the software name is Automation Studio. Once the software is opened, go to the main tree which was located towards the left side of the screen. Find the pneumatic section and expand the tree. Once the tree has been expanded, go to compressors and amplifiers, drag and drop the fixed displacement compressor without input port. For the convenience, zoom in the work plane to clearly see the circuit elements. Now go to Fluid Conditioning, double click on the other entities, drag and drop the conditioning unit, which we are calling it as FRL unit. This conditioning unit has three sections. One is filter, R is regulator, and L stands for lubrication. Once we drag and drop the FRL unit, right click on the entity, go for transformation and rotate towards left side. Now directly connect this conditioning unit to the compressor. Now go to the tree, find the pressure valves. In the pressure valves, expand the tree, go for pressure relief valve. Once you double click on the pressure relief valve, you can find the different varieties of pressure relief valves, and I am dragging one of the pressure relief valve and going for transformation, rotate it to 180 degrees. Placed as per our requirement, and connecting this pressure relief valve to the output port of the FRL unit. Now go to the tree, find directional control valves, expand the tree of directional valves, find the 4x2 way valve, drag and drop manually operated 4x2 way direction control valve. Connect the output port of the FRL unit to one of the input port of the 4x2 way direction control valve. Now go to the flow lines and connections, find exhausts folder, double click on it, drag and drop the exhaust entity and connect to the other output port of the direction control valve. Now go to the tree, find check valves, double click on the check valves, drag and drop the check valve, go for transformation, rotate 180 degrees. In the same way, go to the flow valves, which was located just down the check valves. Double click on the flow control valves. You will find the variable throttle valve. Drag and drop beside the check valve. Connect the input port of the check valve to the input port of the variable or throttle valve, and also the output port to the output port of the check valve. Now go to the cylinder, find double acting cylinder, Drag and drop the double acting cylinder into the work plane and connect the output port of the throttle valve, variable throttle valve, to the double acting cylinder. The other port of the double acting cylinder is connected to the 4x2 way directional control valve. Now go to the measuring instruments, drag and drop pressure gauge, hold control key and drag the pressure gauge in a multiple times to connect this pressure gauge before entry into the variable throttle valve and after variable throttle valve, and also the exit port of the double acting cylinder. Now double click on the variable throttle valve. We will find the data for the variable throttle valve. In that, find the internal diameter and change the value from 1 to 0.2, and we will see the behavior of the circuit by simulating the circuit. Just click on the port of the 4x2 way direction control valve. You will observe the movement of the piston in the double acting cylinder. The piston moves very slowly since we have given the value 0.2. As soon as we release the push button in the 4x2 direction control valve, the piston reverts back to its initial position with a rapid speed. You can also click on the port chamber, which will activate the movement. Stop the simulation. Double click on the variable throttle valve. Now change the value 0.2 to 0.5 and check the speed of the double acting cylinder. We observe the speed has been increased. Stop the animation. Again double click on the variable throttle valve and change the value 0.5 to 1 and go for the simulation. You will observe the speed of the double acting cylinder greater than that of before we have given the 0.5 value. In this way, we can control the speed of the double acting cylinder by using pneumatic circuits in the Automation Studio software.